Hello everybody. In this video let us see some practice bits on Carnot engine as well as first law of thermodynamics. First, the change in internal energy of gas is directly proportional to internal energy totally depends upon the change in temperature only. So it is proportional to change in temperature. Right? It is proportional to change in temperature. Now specific heats of gas at constant volume Cv and constant pressure Cp are related as Cp minus Cv is equal to R by J. J we call mechanical equivalent of heat, or Cp minus Cv equal to R, or Cp minus Cv equal to R by J, J mechanical equivalent of heat. The first law of thermodynamics is nothing but it explains about the law of conservation of energy, is conservation of energy itself only. Now here he gave a question. A combustion experiment is performed by burning a mixture of fuel and oxygen in a constant volume bomb. What he said? Constant volume bomb, he said, surrounded by water bath. During the experiment, the temperature of water rises. Regarding the mixture of fuels and oxygen as system, he gave options what is happening. In that, the right option is, now here, what is happening? During the experiment, the temperature of water rises, we said. Next here, we performed the mixture of fuel and oxygen in constant volume, we said. So, now from first law of thermodynamics, we know delta U equal to Q minus W. What is the first law? Actually, dQ equal to du plus dW. Right? From that, du equal to dQ minus dW. No, the same thing I wrote, Q minus W. Here, W means what? PdV. Constant volume, he said. So dV equal to 0. When V is constant, dV equal to 0. So work is 0. Now next here, mixture of fuels is taking place, he is saying, fuel and oxygen. Means here, heat transfer is taking place, we can say no. Right? So heat from fuel to oxygen, it is transferring in such a way. So here heat is evolved, so we take Q with a negative sign. W 0. When Q is negative, then as heat transfer is taking place, automatically the internal energy also decreases, and that also taken as negative. So Q negative, W 0, delta U negative. When he gives such kind of questions, we have to think in such a manner. Next, a thermos bottle containing coffee vigorously shaken, and thereby the temperature of coffee rises. Regarding the coffee as a system, what happens? Here he took thermos bottle, means there will be no heat exchange because it is perfectly a non-conductor. So there is no heat exchange. Now here we are shaking the coffee vigorously, means we are doing certain work on the coffee. The work done on the system is taken with negative signs. And here the internal energy rises, he said. Temperature is rising, means internal energy also rises, directly proportional, no. So it is taken as positive sign. Right? Now the next question. A resistor immersed in running water carries an electric current. Consider the resistor as a system. Resistor means no current transfer take place. Right? It opposes the current or heat. So Q equal to 0. Right? Now next here, The resistor is immersed in running water, carries an electric current. It is immersed in running water means in order to forward the current it has to do some work. So work will be done on the resistor. So it is taken by negative sign. Right? Now delta Q equal to Q minus W. No? Here Q is 0. Work is done on the system means minus W we will write no, and minus minus plus. So internal energy rises. Now next, the device which convert heat into mechanical work is simply heat engine. A reversible heat engine can have 100% efficiency if the temperature of sink is 0 Kelvin, right? Actually, heat engine work is between source and sink, no? If sink is not there, it can have 100% efficiency. Now, in heat engine, maximum heat that can be converted into mechanical work depends totally upon working temperature. Okay? In a refrigerator, the heat exhausted due to outer atmosphere will be more than absorbed from the contents. The heat exhausted to the surroundings is more than the heat absorbed from the contents. This is the natural thing which we see in the refrigerators now. How much it exhausts or transfers the heat to the surroundings compared to the absorption, it will be less. Work done during isothermal process, RT log E V2 by V1. Now next, if a system A is in thermal equilibrium separately with B and C. Now I took a system A, B, C. He is saying that A and B are in thermally equilibrium, means separated with non-conducting wall, or we can say adiabatic wall. AC, BC are separately in separately in contact to each other, means it is separated by conducting wall, or we can also call it as diathermic wall. Then when A and C, B and C are separately in equilibrium to each other, then automatically AB will also be in equilibrium to each other. This we call it as zeroth law of thermodynamics. Right? In a cyclic process, how work done will be there? Work done by the system will be equal to the quantity of heat given to the system. Right? Now next, he gave a question. 1 mole of a perfect gas expands adiabatically. As a result of this, its pressure, temperature and volume changes from P1 T1 V1 to P2 T2 V2. If molar specific heat at constant volume is CV, then work done by gas. So he is saying that P1 T1 V1 changes to P2 T2 V2 and the work is done adiabatically. Here gas expands adiabatically. He is saying if molar specific heat at constant volume is CV, then work done by gas. Generally in adiabatic process work done is R by gamma minus 1 T1 minus T2. Now the difference between specific ratios Cp minus Cv equal to R and Cp by Cv equal to gamma. We substituted these values and simplified. So Cp minus Cv by Cp minus Cv by Cv. T1 minus T2. So we will get Cv T1 minus T2 is the required answer in terms of specific heat of a constant volume. Work done in adiabatic process. The ratio of specific heats Cp by Cv means gamma. The value will be 1.40. Now the next one, using the second latent heat equation, he gave C2 minus C1 equal to dL by dt minus L by T. he gave show that specific heat of steam is negative. He gave certain options. We have to substitute that options and we have to see with which option answer we are getting specific heat of steam is negative. So here first I took 800 minus 0.705 T. So L equal to, now I am differentiating this, dl by dt becomes constant 0 minus 0.705. Now boiling point of water, steam he said no, means boiling point of water 100 degrees Celsius. I converted into Kelvin, 100 plus 273, that is 373 Kelvin, right? Now I am substituting this in T. So 800 minus 0.705 into 373, that is 537. Now specific heat of water in liquid state 1. Now in problem he gave C2 minus C1 equal to dl by dt minus L by T. He is asking to find the C2 is negative or not. So now sending C1 to this side, C1 plus dl by dt minus L by T. So 1 plus minus 0.705 minus 537 by 373. Answer comes out to be minus 1.14. So the negative value of steam comes for L equal to 800 minus 0.705 T. So in such a way we have to check the options and we have to see whether the required answer is coming or not. Now next, the Clausius-Clapeyron equation indicates that an increase in pressure increases the melting point. So when pressure increases, melting point increases. In such cases, substances contract on solidification. Right? Now next, if degree of freedom of gas is n, then ratio of Cp and Cv. We know Cv means du by dt, change in internal energy by temperature. So d by dt, now u value will be n by 2 RT. So differentiating it, we will get n by 2 R. So Cp minus Cv equal to R, we know that. So Cp equal to Cv plus R. So now Cv value we got as n by 2 R plus R. So n by 2 plus R I took as common. Now he is asking the ratio, no, Cp by Cv, that is equal to Cp value n by 2 plus 1 into R and Cv n by 2 R. Simplifying we get 1 plus 2 by n is the answer. Now the next question, a given amount of heat cannot be completely converted into work. However, it is possible to convert the given amount of work completely into heat. This statement comes from second law of thermodynamics. Heat, 100% heat cannot be converted into 100% work, but 100% work can be converted into 100% heat. That is said by second law of thermodynamics. Now for a stable thermodynamic system, the temperature dependence of internal energy, it decreases for stable thermodynamic. So the curve will be in such a way. Now next, on suffering adiabatic expansion, the internal energy of gas decreases. Adiabatic we said, no heat transfer will be there. So internal energy decreases. Cooling is produced in adiabatic process, cooling will be produced. The gas cools. The quantity remaining constant in isothermal expansion, what we will say, temperature or internal energy remains constant in isothermal. Temperature constant means internal energy constant. For thermodynamic system, work done in process depends upon path. It is a path function. Work done in isochoric, P V2 minus V1. Okay. Now next, in case of system goes reversibly from an initial state to the final state adiabatically. In a case of system going reversibly from initial to final state adiabatically, work done is same for all neighboring adiabatic paths connecting these states. Right? Now the next question, Work done by gas in adiabatic expansion. So all the area under this curve will be equivalent to the work done. This will be the graph. In PV diagram, he gave such a graph A, B, C, D. The area ABCD represents work done in the process. This area represents work done in the process. If T1 and T2 are the temperature of two reservoirs, where T1 is greater than T2 and a Carnot engine being separated them will have the efficiency of Carnot engine. Work output by heat input W by Q1. So Q1 means RT1 log E V2 by V1. Q2 also RT2 log E V2 by V1. So substituting all the values we get efficiency as T1 minus T2 by T, or we can also write 1 minus T2 by D1. Now next, when perfect gas is supposed to expand freely against the vacuum in an insulated vessel, gas has undergone, we can say, change in temperature. In isothermal change, the internal energy of molecules does not change, because isothermal means temperature constant. No, temperature constant means internal energy constant. So it does not change. The slopes of isothermal and adiabatic curves are related as adiabatic curve slope is equal to gamma isothermal curve slope. Adiabatic curve slope is equal to gamma into isothermal curve slope. The absolute zero is the temperature at which isothermal and adiabatic processes are identical. The absolute zero is the temperature in which isothermal and adiabatic processes are identical. It is a true statement. The temperature of surface of sun is approximately 6000, and he took a big lens and focused the sun rays and tried to produce a temperature of 8000. This violates second law of thermodynamics. Why? Means here heat transferring is taking place from 6000 to 8000. We are improving, and heat transfer from cold body to hot body is impossible. So it violates second law of thermodynamics. If W is the work done by system against its surroundings, then W starts for work done on the system. If internal energy of a perfect monoatomic gas at 27 degrees Celsius is only kinetic, the efficiency of Carnot engine working between heat reservoirs at temperature 327 degrees Celsius and 27 degrees Celsius respectively are. So 327 T1 converting into kelvins plus 273, 600 kelvins. 27 degrees Celsius also converted into kelvins plus 273, that is 300 kelvin. So eta equal to T1 minus T2 by T1. That is equal to 600 minus 300 by 600, that is 1 by 2, that is 0.5. By into 100 if we do, we will get efficiency as 50%. Now next, let a delta Wi amount of work done when gas is compressed isothermally to volume V. Delta Q amount of heat absorbed by the gas. The delta Wa amount of work done when gas is expanded adiabatically. So delta E, change in internal energy of gas to complete the process. Then delta E is written as delta Q minus. So delta E is change in internal energy, he said. So it is written as delta Q minus delta Wa minus delta Wa. Here generally change in internal energy, instead of U he said E. Delta U equal to delta Q minus delta W. Now delta W is written as work done when it is isothermally compressed. So taken as positive. Now work done adiabatically expanded, positive. Substituting delta Q equal to delta E equal to delta Q minus delta Wi minus delta Wa. Right. Now next, an engine absorbs heat at a temperature 1000 Kelvin, rejects the heat at 600 Kelvin. If engine operates at maximum possible efficiency, amount of work performed by engine at 2000 joules. Formula is maximum possible efficiency is efficiency 1 minus T2 by T1 into 100. 1 minus already he gave in Kelvin, so no need of converting. 600 by 1000 into 100. So 40% we will get. So thank you for watching my channel Reshma Physics. So if you like my video, like it, share it, subscribe it. Stay with my channel to receive more videos for on the topics of entrance test of TS set as well as JL exams. Thank you.